Ramy, the floor is yours. Yeah.
Good evening, everyone. Thank you very much for being here this evening. First of all, we thank the organizers of this event for their huge efforts. First of all, thank you, Peter, for introducing me. I'm Ramy Rashad Hashim. I'm currently doing my PhD here at the University of Twente in the Robotics and Mechatronics group. And today my talk will be about unmanned, the applications of unmanned aerial vehicles, UAVs for short, drone for media coverage. You can call them a lot of names, but they're flying machines, so we can just call them that, or flying robots. And I'm going to talk about the operation of unmanned aerial vehicles, but we're going to choose one of these drones. Since the very earliest times, since the very earliest civilizations, human beings have been dreaming about flying. And the story of flying machines started way before the Wright brothers were able to perform manned power flight in 1905. One of the earliest attempts of flying was with gliders and was recorded for Abbas ibn Firnas, one of the Andalusian inventors in the Islamic Golden Age, I think it was in the 9th century. And even after that, people started to try to develop flying machines. Even Leonardo da Vinci, one of his sketches was found to be a replication or trying to design a wing of a manned power flight. And many people spend all their lives trying to get machines to fly until the Wright brothers were successful in doing that. However, once we got these machines in the air, we started off thinking how to make them autonomous. The first autonomous airplane was developed in the First World War by two American inventors, Hewitt and Sperry, and they were successful in making it perform sustained autonomous flight for long hours. After that, in the Second World War, the German army was successful in deploying the first cruise missile, and they called it the V1 flying bomb, and you can of course guess what it was used for. And for the past 70 years, the military applications have been the main driving force for aerial robotic research all over the world. And this trend has started to change in the past years. There has been a lot of civilian applications that are now demanding the presence of aerial robots in them, because aerial robots provide cost-effective solutions to a lot of engineering problems. And that's why today I'm going to discuss some of the civilian applications of aerial robots that can impact societies worldwide. And the list of civilian applications of aerial robots, or drones, is a very long list. These are just a few examples. First of all, one of the main applications of aerial robots is remote sensing or visual inspection. Currently, drones, as we speak now, are used for inspecting solar panels, they are used to monitor power lines, and they are used to extract samples out of volcanoes. Moreover, drones are currently used for monitoring pipelines and for exploring unexploded mines, for detecting them. In these applications, the drones act just as a flying sensor, where they provide visual feed to the inspection operator on the ground during the inspection operation. Another application of drones in the civilian sector is disaster response. Before, in the Fukushima nuclear disaster in 2011, 6 years ago, drones were deployed just after the accident to gather imagery of the scene, to inspect what's going on there, because humans cannot go into these dangerous places. And moreover, drones are used for firefighting, and they are used also for chemical plant inspection, and they are also used for wildfire management. Another application for drones, which is widely used, is for surveillance. Drones, as we speak, are used for traffic management in some places around the world, and they are widely used for law enforcement. Take, for example, our group here in the University of Twente, which is the Robotics and Mechatronics group. We already have a collaboration with the Dutch National Police in order to develop a software architecture where the Dutch police can connect the different robotic platforms they already have. Another application of aerial robots is payload delivery. Large companies like DHL and Amazon have already started delivering payloads, delivering packages to their customers using drones. And another also interesting payload delivery application would be delivering pizzas. And last year, Domino's Pizza started a pizza drone delivery service in New Zealand. And they are now thinking of 6 more other markets. And guess what? The Netherlands is one of their markets. So you might have a pizza delivered to your house using a drone soon. And one of the fast-growing applications of aerial drones in the civilian sector is for entertainment. A lot of people buy drones just for fun. Because drones can be used for video shooting, they can be used for telecasting sport events, and they can even be part of a theatrical show. Last year, on Broadway, drones were used to make flying lampshades as part of a theatrical show. It was called Paramour, and yeah, you can check out that show. It was very nice. So these flying lampshades were actually just flying robots, and they had a cover. And the list can go on and on and on. We can spend in this hours. The current trend of research in the robotics community, the robotics research community, is to take these aerial robots to the next step. In all of these applications, as you have just seen, the drones were just as a passive observer in the scene. So they were only acting as a flying sensor. You put whatever sensor you want on these drones, and then you already have them suitable for the applications we just discussed. Currently, researchers are trying to take drones to the next level where they act as manipulators, as flying manipulators, to interact with the environment for order to extend the applications of aerial robots. For example, here in the robotics and mechatronics group, we already have a lot of projects going on trying to have contact-based inspection or interaction of drones with the environment. And the thing is that you cannot use the normal conventional drones for interacting with the environments. Take, for example, this research done in our group here. If you put a manipulator on one of these conventional robots, like the one you've just seen, and you try to interact with the wall, this is what will happen. That's because aerial robots, the conventional aerial robots, are designed only for flying, not for interaction. However, if you design them for the purpose of interaction, for example, in our group we've designed a special mechanism that can absorb the impact and then can allow the drone to perform the inspection task, it will perform like this. Okay. What you just saw is that the drone was able to interact with the wall, remain in contact for some seconds, and then fly back without crashing. And this is a scenario for a contact-based inspection. For example, on any structure, to perform context-based inspection like non-destructive testings. Another research we had in our group, is this research. No problem. Yeah. Okay, this one was just a repetition. If you look at this, for example, the lower right corner, you find that this was another research done in our group to develop a mechanism that can perch on smooth surfaces. So, for example, if you have these drones, one of their main limitations is that it has limited flight time. So, to perform inspections for a long time, in our group, we designed this mechanism which can perch on smooth surfaces. For example, simulating a wind turbine surface, you can just perch on the surface, turn off your rotors, stay up there for hours, do whatever type of inspection you want, and then fly back to the ground, just like what insects do. And once researchers get this kind of research to the mature level, we can use aerial robots for example, manipulator tasks. You can use drones to interact with objects, like this research. Or you can even make much more complex behaviors using these aerial robots. So now let's get into some technical details. How do these drones fly? How do they do it and stay in the air? But this talk can stay all along for hours because there are so many types of drone out there, and each one of them has a different principle of operation. You can classify the different drones out there into 4 types, at least 4 types. One of them is fixed wing UAVs, fixed wing drones, which are similar to the airplanes you all see around. Another type is the rotary wing drones, which is similar to the quadrotor Abhijay was just demonstrating with. Another type of drones is the flapping wing drones, which are inspired from nature, like this one, which is bio-inspired from the hummingbird. And you can have all sorts of hybrid drones. Like, for example, this one is called the tail sitter, and it's a hybrid design between a fixed wing and a rotary wing drone. So now let's focus on the most popular drone that anyone, even small children, know about, which is the quadrotor, the one up on the right. And if you want to know why is the quadrotor the most popular, let's see what's the quadrotor made of. In order to, you can make this at your home, go back, pass by Media Market, you can buy the components and with maximum of 200 euros, and you can make a drone at home. You all you need is a frame, a mechanical frame to put the avionics on. This frame is made out of lightweight material, like carbon fiber and aluminum. You need 4 motors, 4 electric motors, and we use in these applications a special type of motor called a brushless DC motor. On each motor you need a propeller, which is used to produce thrust in order to lift the drone up from the ground. You need a power source, which is just a battery like the one you have in your smartphones. And you need a lot of sensors, or a lot of electronics. Along these electronics are different sensors which tell the quadrotor how it's behaving, what's its speed, what's its angle with respect to the ground. And most importantly, it has an onboard computer to do a lot of computations in order for the quadrotor to remain airborne. So if you have these stuff and you need something to control the drone with, to tell it how to move, you can do this with a remote controller, you can do this with your laptop, or you can even do this with your smartphone with the right applications. And by this, you already have a drone flying. Of course, it will not fly except if the onboard computer has the correct software for it to fly, but you can easily buy this commercially, and there are a lot of commercial flight controllers that you can buy off the shelf and have this drone flying in no time. And because the quadrotor is, you can only make one for 200 euros, that's why in commercial applications it's very preferable, even for researchers who have a lot of funding from funding agencies, but they prefer to use sometimes cheap equipment to make a lot of research out of it. So, and that's exactly what happens all over the world. People prefer this cheap drone over other more expensive drones. And this drone, if you have it, then you can do whatever you want with it. So how does this quadrotor fly? How does it hover and stay in the air? As we said before, the quadrotor has four motors, and each motor has a propeller. Once you start to rotate the motors, each motor will produce a thrust force. And for the drone or the quadrotor to start lifting off the ground, the sum of the 4 forces has to be larger than the gravitational force that's trying to pull the drone to the ground. So if you increase the speed of the motors to be higher, to produce thrust force higher than the gravitational force, the quadrotor will start going up. If you decrease the speed of the motor such that the thrust force is less than the gravitational force, the quadrotor moves down, like this. And that's not only how the quadrotor can move, you've seen it in the demonstration before, that it can move sideways, and for order to do that, it has to tilt. It has to perform what's called the pitching motion. And to perform this pitching motion, it can only do that with 2 of the 4 motors. So for example, if you have these 2 motors, and if one of them is producing a higher thrust force than the other one, the quadrotor starts to tilt, and once it tilts, it has to move in this direction. And the opposite is also true. So if you have this propeller faster than this propeller, the quadrotor tilts in the other way, and it moves to the back. And also that's true for the other two propellers, which make what's called the rolling motion, and it moves the other diagonal direction. So these are the three the motions that the quadrotor can make, and there's a fourth one which is called the yawing motion, or just spinning about its axis, just like spinning your head. So with these four motions, the quadrotor does what you have just seen. It can move around. So that's the upward motion, the pitching motion, the rolling motion, and the yawing motion. And for the quadrotor to stay in the air exactly in its right position, it needs to compute a lot of calculations to send what speeds should each motor be in order for the quadrotor to remain in the air. That's done in the onboard computer on the quadrotor, and it does it more than 200 times per second in order for the quadrotor to stay in the air. So once you have this quadrotor flying, you can do with it anything you want, and literally anything. And the whole trick, what researchers around the world are trying to do, is change the piece of software that's written inside the computer. So if you write a more sophisticated algorithm in the computer, you can make the drone do anything, and literally anything. You can make the drone fly through hoops. You can make the drone balance a pole. You can make the drone juggle a ball. And you can make a lot of them move together in one formation. So these machines have a lot more to give us. And now what the civilian sector is trying to do is find applications which use these drones. These drones provide cost-effective solutions to a lot of our problems that we have around us, and drones are not only used nowadays by the military. And in the coming years, the civilian applications that are demanding aerial robotics research is becoming more importantly than the military applications that are currently available. So, and these drones are coming real fast, and once you'll find them in one day, starting to invade all of our lives, and one day each one of us will have a drone inside his house. So until that day comes, do not be afraid of drones, and remember that some people are using drones to build societies other than to destroy societies. So if you hear the phrase that the aerial robots are coming, please do not be afraid. Thank you.